Welcome to section 4.2, day 2, applications with angle measures. Today we're going to solve problems involving arc length. We're going to find angular and linear speeds, and we're going to find the areas of sectors of a circle. First thing is arc length. If theta is a central angle in the circle of radius r, then the length of the intercepted arc, s, is given by the formula s, the arc length, equals the radius times the angle measure in radians. To do this, we must be using radians, doing arc length. So we take arc length is radius times the angle measure in radians. Here it says, to find the exact length of the intercepted arc in a circle with a central angle measure of pi thirds and a radius of 4. This is just S is r theta, our radius is 4, we're multiplying against our angle of pi thirds, and we get 4 pi thirds, or 4 thirds pi, however you want to write it. This is the exact length. Find the length of the intercepted arc in a circle with a central angle measure of 125 degrees and a radius of 7 centimeters. This is again r theta, but theta has to be in radians. So we're going to do our conversion all at the same time. Right now we have 125 degrees, but we want this in radians, so we need to multiply by pi over 180 degrees. The degree part will cancel out, just the degree symbols, leaving this in just terms of radians. Here it says to round to the nearest tenth, so you have 7 times 125 times pi, all divided by 180, and we get 15.3 centimeters when we do this on our calculators. That is finding arc length. This is something you've done in the past. Now this is something new. Linear and angular speeds is another key concept. So suppose an object moves at a constant speed along a circular path of radius r. If s is the arc length traveled by the object during some time t, would it be hours, minutes, or seconds, or whatever you're going to use for time, then the object's linear speed is given by v equals the arc length over time. That is our speed. If theta is an angle of rotation in radians, so how many times we're going to rotate around a circle, or how many times we're going to rotate on an arc through which the object moves during time t, the angular speed, this is a W symbol, which stands for omega. This little symbol is the omega symbol, if you were curious. So this is given by omega is theta over time. With the speed, if we aren't given the arc length, this is the same. We're going to get this as v is r times the angle measure. The arc length is r theta over t. So quite often we'll have to find the arc length by doing the radius times theta. All right, we're going to use these, demonstrate how we use these to solve problems. First, we have a vinyl record. Has a diameter of 30 centimeters. When played on a turntable, the record spins at 33 1/3 revolutions per minute. Find the angular speed in radians per minute of a record as it plays, round to the nearest tenth. So we want the angular speed. That is our omega is equal to theta over t. Well, our theta part is we're doing a full time around a circle. So a full time around a circle is 2 pi for radians. And we're doing this 33 1/3 times a minute. So we're going to multiply this by 33 1/3. We're already given our time because it's per minute. Be careful if you do this on a calculator. This is 2 pi. We're multiplying by 33 plus 1/3. And when you do this on a calculator, you get 209.4 radians a minute. This is my angular speed. We want to find the linear speed of the outer edge. So we're going to find in the edge of the record, is it spinning? How fast is it moving? We want this in centimeters per second and round to the nearest tenth. So we're trying to find is the total arc length that it travels over time. Over, in this case, we're doing it per centimeters per second. We'll just use time for now, and I'll show you all the conversions. To do this, we have V is S over T, which is, we don't have the arc length right now, so R theta over T. We do know a couple of things. To find S, or the R theta part, we have the radius of our album, or our LP, is 15, half the diameter. And we are doing this, we're doing a full revolution every time, so that's 2 pi. But we are going 33 1/3 times per minute. So our arc length is all this together. So this part right here is just one time around, but we're doing it 33 1/3 times around per minute. When you multiply this together, again, make sure you use that 33 plus 1/3 in your calculator. You're going to find that this is 1,000 pi centimeters a minute. But we want this in seconds. So we have 1,000 pi centimeters a minute. We want to get rid of minutes to make it into seconds. So 1 minute has 60 seconds in it. So you're basically going to take 1,000 pi and divide it by 60. And when you do this, you get 52.4 centimeters every second. That's how fast the edge of the album is moving. 52.4 centimeters every second. Quite often when we do these linear and angular speeds, we have to do some conversions in them, so watch out your units of measurement. Let's do one more of these. Find the angular speed of a carousel in radians per minute. If the diameter is 6 feet and it rotates at a rate of 10 revolutions per minute, then find the linear speed at the outer edge of the carousel. This is similar to the last problem we did. First, we want our angular speed. We're looking for the omega, and this is our theta, our angle measure over time. Well, we have doing it 10 revolutions per minute. And every time we go around a circle, we are going 2 pi radians. So we are doing 20 pi radians a minute, which when you do it on a calculator is 62.8 radians per minute. That is our angular speed. We want to find our linear speed, which is the arc length over time. To find our arc length, we have 10 revolutions. We have a diameter of 6. So our radius is 3. This is, our S is R theta. Our radius is 3. Every time we go around a full circle, we have 2 pi. So we have 3 times 2 pi. And we are going around 10 times. So we have to count for that. We are going around the circle 10 times. Gives us our denominator for minutes. So we have 3 times 2 times 10. We have 60 pi feet a minute. And when you run this in a calculator, you get 188.5 feet per minute. That's how fast the outside edge of the carousel is moving when it's rotating. All right, that is finding linear and angular speeds. The last piece for the day is finding the area of a sector of a circle. The area A of a sector of a circle with radius r and a central angle theta is, area is 1/2 r squared theta. Generally we do area, if we just had, is pi r squared. And then we figure out what part of the circle we want. Well, since we're doing sections of a circle, the angular measure is giving us that part of a circle, the theta piece. And to go around a full circle, theta is 2 pi to go around a full circle. And since our angle measures are in pi form, and we do like 7 pi fourths, to account for this, when we put our angle measurement in terms of pi, we have to divide out that 2. So we're just in terms of pi. That's where that half comes from in front. Because we do angle measures in terms of pi, and a full circle is 2 pi, to wipe out the 2 in front of the pi when we do the full circle, we have to divide by half. So let's use this. We have to make sure, again, we are measuring in radians to do this. So here we have, find the area of the sector of the circle. From the other slide, our formula is A is 1/2 r squared theta. All we have to do is plug our numbers in. We have 1/2, the radius is 5, so 5 squared. Theta is 3 pi fourths. And when you multiply all this together, you get 29.5 meters squared, because we're doing area. For the bottom one, we do not have it in radians yet. We do have 1/2. We have our radius is 8. But we need to change the angle measure from degrees to radians. So we have 60 degrees times pi over 180 degrees. And when you do this part, you should get 33.5 feet squared. And if you want to do the conversion off to the side first, you can. You could say theta equals 60 times pi over 180, which is pi thirds. And instead of having this here, you could use pi thirds instead. It's up to you how you want to set it up, as long as you get the right answer and your math is correct. All right, that is find the area of a sector of a circle. All right, this is 4.2 day 2. Today we looked at arc length, we looked at angular speed, and we looked at linear speed, and then we looked at the area of a sector of a circle. Thank you for watching, and have a nice day.